Have you ever wondered how big companies manage to screen thousands of resumes for a single job opening? The old way of doing it manually is slow, inconsistent, and frankly, a huge pain. So, today we are going to pull back the curtain and show you how we built a complete end to end automated resume relevance checker using Python large language models and Streamlit. By the end of this video, you will see a deployed web app that automatically scores resumes, highlights missing skills, and even gives personalized feedback to candidates. So let's get started. So before diving deep into the technicalities of the project, let's test it. So this is the job description. So we'll select the JD2 that is uploaded. Then resume, we'll upload it. Select the resume code font. So start relevance analysis. So here the analysis is going on, you can see. So you can see here the dashboard. So it is the relevance score is mentioned, which is 43% out of 100, and resume, the missing skills it is mentioned here. You can see the work on data engineering and the data visualization that are mismatched, and the detailed feedback. This is the most important thing. The verdict given is the medium feedback by the large language model, and this is the detailed feedback given by the LLM and the missing skills. So that is not mismatched. So let's dive deep, or let's see the another file. Well, let's take 7th. Start relevance analysis. You can see here it is given 41% for this resume. So I think it is the verdict is medium feedback. So missing skills mentioned as same as above one. So this is a relevance score, and the verdict is given here, and the missing skills given here, and the feedback, the detailed feedback is given here. So you can see here about the system, the project objectives. The problem is simple. Manual resume screening is inefficient. It leads to delays and inconsistent judgments. Our goal was to build a system that is robust and scalable, and most importantly, provides actionable insights. So here in Innomatics, like we have like many centers in Delhi, NCR, and Pune, and Bangalore, and Hyderabad, where the lot of resumes will be screening, and the for the recruitment or the placement team, it is like the hectic, it is like a tedious process to filter out the resumes. So to solve these problems, we have used use the hybrid engine or hybrid AI engine. It consists of the hard match and also the soft match. Where the hard match a keyword based check to see if a resume contains the exact skills from the job description, and the soft match a semantic analysis using large language models to understand the contextual fit, even if the keywords don't match exactly. So this is the project folder, complete folder. Then we'll open it in VS Code through command prompt terminal. See, we have used modular coding for the scalability and reusability instead of writing the whole code in the Jupyter notebook cell by cell. And in this project, at its core, RAG concept is used, retrieval augmented generation. We are grounding our large language model in a specific knowledge base, our resumes and job descriptions, to get a factual relevant results. So we'll go step by step. So initially, I have initialized the project folder structure. Then I created the separate environment for this project to install the requirement libraries or the packages for the project. So then I created the folders that are the required for the project. And also you can see here in the requirements.txt file, I have like I have used resume and JD parsing and NLP and text processing tools, the packages, and the RAG orchestration and the embeddings models like the LangChain and LangChain community and LangGraph OpenAI model, and the Fire CPU, which is a vector store we have used, and the ChromaDB also vector store. But I have used the Fire CPU. These are the open source vector store models, and the tick token. These are the tokenizer for OpenAI models. LangChain, this is the framework to build the RAG applications or the AI-powered agents. And these are the configuration login and utils, Pydan, Pydantic and Python.env to load the .env file, and the backend and frontend. See, now we have used the Streamlit for the minimum viability product for the dashboard for the recruiters. So these are the required libraries or the packages we have installed in this project. So let's see step by step. So phase one is data ingestion. Here you can see data is given. These are the raw data, resumes and JDs, job description and the resumes and scripts. In the source file, you can see the data ingestion. We have parsed the job description and also we have parsed the resume and then cleaned. So this is the foundation step. The first and most critical step, and it is also garbage in and garbage out, right? We had to build a robust pipeline to read our PDF and docx files. This is where the real work happened here. So this complete approach is a modular for the scalability and reusability. So actually we have started with the simple regex, but quickly realized it was not enough. So here the job description parser and the resume parser are the heart of this phase. So we then used an orchestration script to ingest. Here you can see. So we then use the orchestration script for the pipeline. In the scripts you can see ingest data.py. This is the orchestration script. To run this process on all of our files and save the clean structured data into a JSON format. So this clean data is the foundation for everything that comes next. This is the output of this is the JSON format. So then with our clean data, we have done the embedding. Where it is in source, embeddings, embedder.py. This is the whole script of the embedding. So in this we have used the OpenAI model, embedding model, to convert our resume and job description text into numerical vectors. These vectors capture the meaning and context of text and allowing for a deep semantic comparison. Like for our hybrid scoring, we have used to do two components. Hard match with BM25. Instead of brittle keyword matching, we implemented BM25, a powerful ranking algorithm that accurately scores keyword relevance. This fixed the issue where our score was almost less prior because of the slight formatting differences. So then we have used soft match with the cosine similarity. Here in the relevance analysis, you can see here, this is the hybrid scoring. general embeddings for the soft match, and the performance embedding for the scoring. Soft match with cosine similarity. So we use cosine similarity to compare the embedding vectors. This gives us a percentage score of how contextually similar a resume is to a job description, which is a powerful signal. So that's how we have calculated the relevance score. So we then combine these two scores with a weighted formula to get our final relevance score, which you saw on the dashboard earlier, which is here. This in the dashboard, you can see this is a relevance score, combination of hybrid and combination of exact and search, semantic search score. So a powerful backend is useless without a great user interface, which is Streamlit. Here we are using. So then this app.py is the final script, ties everything together. Calls our backend file uploads, calls our backend relevance analyzer.py function, and displays the results in a clean professional dashboard. And the verdict column uses colored badges for a quick visual cue. So, so finally, we needed to make our app accessible to everyone. We used Hugging Face Spaces. This is the Hugging Face Spaces. We have deployed it on Hugging Face and hosted with the Streamlit, and also deployed it on GitHub. The process was straightforward. We created a new space and cloned the empty repository. We copied all of our code into it. We set up our APIs keys securely using secrets.toml and .env file. And with a few simple git commands, we have pushed our project alive. So this is how we have built a solution for the real world problem statement. These are the project objectives and the tech stack. The tech stack we have used, the tech stack front end Streamlit we have used, in the back end Python, LangChain and OpenAI. And scoring, you can see here the parsing techniques. We have used the PyMuPDF and the Python docx for the text extraction. For the scoring, hybrid approach combining keyword matching and the LLM semantic analysis. And for the embedding, we have used the OpenAI embeddings for the contextual understanding. So this is how we have done. We have solved the solution for this problem statement. So that's how we have built the robust parsers and implemented the hybrid scoring and created a user-friendly interface. I hope you enjoyed. Thank you.